Now let's start motion in a straight line. See, in physics, we discussed this thing already. We try to explain different phenomena. We try to understand nature. If we want to understand nature, if we want to explain the phenomena which we observe in our day-to-day life, then first of all, we have to start study with motion, because each and every object, each and every particle in this whole universe that is in motion. But directly we can't discuss those motions which are actually executed by the objects or the particles, because these motions are complex or complicated motions. So first of all, we have to start with the simplest type of motion, and that is motion in a straight line. Then first of all, we have to understand what is motion. Motion means when any object is continuously changing its positions with time, then we can say object is in motion. And when object is moving only in one direction on any one axis, then we can say that is motion on a straight line, and that is also known as rectilinear motion. Now, the studies related to motions are carried out in the branch of physics named as mechanics. Mechanics is divided in two parts: kinematics and dynamics. Kinematics, that is the branch of mechanics in which explanation of motion is given without discussing causes of it. Means just we have to explain the motion. Which type of motion is this one? That will be discussed. But why the motion is of this type? That will not be discussed here. Okay? Dynamics, that is the branch of mechanics in which the explanation of motion is given with its causes. With its causes. Okay? Now, if you want to explain the motion, then we require some physical quantities which we have to associate with that particular motion. So now, first of all, we have to think about position, path length, and displacement. Position of any object. Now, if you want to locate position of any object, then you require the reference point. And here in physics, we will consider the frame of reference, that is the rectilinear coordinates, sorry, that is Cartesian coordinate system. Okay. And now in Cartesian coordinate system, there are three mutually perpendicular axes: x-axis, y-axis, and z-axis. And all these three are mutually perpendicular axes, and the intersection of these axis, that is called origin of the Cartesian coordinate system, and that is considered as reference point. So with respect to that reference point, we locate the position. Suppose we consider motion of particle is only on x-axis, then only x coordinate will change. So with the help of that x coordinate, we can locate the position of particle at any time t. Okay. Then after path length. Path length means what? Path length, that is the total distance traveled by the particle or the object. That is path length. And displacement. Displacement means what? The change in position of the particle or the object that is called its displacement. So from definition, one can understand this thing. Displacement, that is nothing but the shortest distance between final and initial position of the particle or object. So we can write displacement, that is equal to final position minus initial position. Okay. Now let's understand this concept of path length and displacement with example. Suppose we consider motion of any object. Means suppose a car is moving on x-axis. Okay. This one is origin at time t equal to 0. We can say it is at origin at x equal to 0 and say this origin is O. Then car moves to P, then P to Q, then Q to O, and then R. Now, during this particular motion of the car, what is the path length for different part of the journey and what is displacement? Let's discuss this thing. So, the concept of path length and displacement, that will be perfectly clear to all of you. Now see, when the car is moved from O to P, so for this particular journey, path length, that is total distance traveled, so that is 0 to 360 means 360 meter distance is covered. So path length is 360 meter. Now displacement, that is final position minus initial position. Final position is 360, initial position is 0. So 360 minus 0, that is 360 meter. Then consider the journey O to P and then P to Q. So total distance traveled O to P 360 meter and P to Q another 120 meter. So total distance traveled, that is 480 meter. Then displacement, final position is 240, initial position is 0. So displacement is 240 meter. Then after O to P, P to Q and Q to R. Now when the particle or the car, we can say, moved from O to P, the distance traveled 360. Then again P to O, another 360. Then O to R, another 120. So the total distance traveled during the journey from O to P and P to R, that is 840 meter. But displacement, final position, that is minus 120, initial position is 0. So answer is minus 120 meter. Then if we think about the journey O to P and P to O, then total distance traveled, that is O to P 360 meter, then P to O again 360 meter. So total is 720 meter. Displacement, so initial position and final position both are same one. So displacement, that will come to 0. So here one thing that we can understand easily, path length, that will be always positive. Path length, that will be always positive. But displacement may be positive, negative, or 0. As well as we can understand from this one, displacement is always less than or equal to path length. Displacement is always less than or equal to path length. Clear to all of you now the concept of path length and displacement. Now see, motion of any object can be represented by x versus t graph. X, that is the position, t, that is time. This is very important tool to represent the motion as well as for the explanation of motion. Suppose we have position time graph, that is the straight line which is parallel to time axis. So here we can observe this thing. At time 10 second, position is 40 meter. At 20 second, position is 40 meter. At 30 second, position is 40 meter. It implies that now we can say this thing, object is not changing its position with time, means object is stationary or steady. Then suppose the object is covering equal distance in equal time interval. This type of motion, that is called uniform motion. So here, if we draw the graph for uniform motion for x versus t, then graph will be a straight line inclined at some angle with x-axis. Okay, so if this type of graph is obtained for x versus t for any motion, then we can say the object or the particle is executing uniform motion. Uniform motion means in the same time interval, same distance will be covered by it. But suppose object is not covering same distance in the same time interval, then we can say its motion, that is non-uniform one, and its graph, that will be curved one, as shown in this particular third figure. So in this way, with the help of graph, one can represent or explain motion perfectly. Clear to all of you? Any doubt in this one?